Question number 12. The escape velocity is the minimum speed needed for an object to escape from the gravitational field of the planet. An object traveling at the escape velocity has the kinetic energy is equal to magnitude of its gravitational potential energy at the surface of the planet. So what is the concept behind it? It is a 2-mark question. So what we should do? Show that escape velocity for a planet of mass m and radius r is given by the expression v is equal to root of 2gm divided by r. Okay, fine. So what is the equation for gravitational potential energy at the surface? Because it is given that an object traveling at a escape velocity has the kinetic energy equal to magnitude of its gravitational potential energy at the surface of the planet. So a planet is having a mass m and the radius r. So the gravitational potential energy, basic definition is minus g capital M. Small m is actually the mass of the object that is escaping from the surface of the earth, minus g capital M into small m divided by r. So this is actually the gravitational potential energy of the object. And then they're saying that this is exactly equal to kinetic energy of that object. That means half mv square. And the magnitude means we are not considering the sign. So what we should do? We equate the gravitational potential energy of this object to kinetic energy of that object. So we'll equate this because they are actually equal according to the question. So from both sides we can cancel m, and our aim is to make v the subject. So you can cross multiply this 2. So what happens? V square is equal to 2g capital M divided by r. Therefore v is equal to square root of 2gm divided by r. So that is the answer for this question. Clear? Hence be short. B question. Show that escape velocity for mass at the Earth's surface is about 1.1. Mass of the Earth is given. Because what is the equation of the escape velocity we derived? That is g capital M 2gm capital M divided by small r. So substitute it. 2 multiplied by, what is the g value? Capital G value is 6.67 into 10 raised to minus 11. Multiplied by, what is the mass of the Earth? 5.98 into 10 to the power of 24. Divided by the radius of the Earth is 6.36 into 10 raised to 6. So if you are substituting, what is the value we will be getting? 2 multiplied by 6.67 multiplied by 10 to the power of minus 11 multiplied by 5.98 into 10 to the power of 24 divided by 6.36 divided by 10 to the power of 6. Then you take the square root of the answer. What is the answer? So nearly 1.12 into 10 to the power of 4 meter per second. That is the answer for this question. So question 12.2. When the Earth formed, a large proportion of the gas in the Earth atmosphere was hydrogen. Explain why hydrogen gas is no longer a large proportion of the gas in the Earth atmosphere. No further calculation is necessary. At 20 degrees Celsius, the value of root c square is 1900 meter per second for hydrogen. So what is the answer for this question? So there is some connection with the, not some, there is a connection between the previous answer. So when the earth formed, a large proportion of the gas in the earth atmosphere was hydrogen. Explain why hydrogen gas is no longer a large proportion of the gas in the earth atmosphere. What is the value of root means square velocity of hydrogen? That is 1900 meter per second. So here, this is actually a value which is very less, it is less than 1.129 raised to 4. Still, why we are not having a large proportion of gas, hydrogen gas in Earth atmosphere? So the main point we should include here is, if you are speaking about the molecular speeds of hydrogen molecules, we can say that there is a range of molecular speeds. That means, range means this is actually an average value. So that means some molecules possesses a value very higher than 1900 meter per second. Some exactly lower than this. So there is a range of molecular speeds. What is the meaning of range of molecular speeds? If you want an idea, I will give an idea in bracket. What is that? Some molecules possesses faster speed than 1900 meter per second. Okay. So that is the meaning of range. So what happens? So there will be some molecules greater than escape velocity. Okay, escape velocity. As a result, such molecules escapes from Earth atmosphere. So that is the reason why what happens? Hydrogen gas is no longer a large proportion of gas in the Earth atmosphere. Hope you got the idea about the same. Clear? Okay, so that's about question number 12. So move to next question, question number 13.